Hey guys, how's it going? So it's my last lesson we're gonna do on alcohols, which is right here. You gotta know how to name alcohols, carboxylic acids, and esters in science 30. And it's really easy. So take a look. Okay, so basically you've learned what an alkane was, which is like a carbon that's bonded with these hydrogens. That's an alkane. Okay, so carbons and hydrogens bonded together make alkanes. And then we learned about halogenated hydrocarbons. And you know it's a halogenated hydrocarbon because it's a carbon attached to like halogens. And so that's how you know it's a halogenated hydrocarbon. But how do you know something is an alcohol, right? So you know something is an alcohol if it contains OH, okay? So like this here is an alcohol. An alcohol contains the OH group. How would I name this? Okay, well, I see that this is my parent chain because my parent chain is the longest carbon chain. And the longest carbon chain here is 1. So the name of this is methanol. Meth for my 1 carbon chain, because meth means 1. Okay, it's not just the drug meth, okay? And this all is the alcohol, methanol. See how easy that is? Now, you could do another one. I could do this. Okay, what's the name of this? Well, what's the longest carbon chain? 1, 2. This is the longest carbon chain. What's the name of this? Okay, well, first of all, I know it's an alcohol because it has an OH group. Alcohol, okay? So what's the name of it? Well, the longest parent chain has 2 carbons. So this is called, okay, ethanol. Ethane for the 2 carbons, the OH for the alcohol group. That's it. That's all you gotta do when you name alcohols. If I gave you this, CCCOH, what would be the name of that? Hey, guess what? 3 carbons means it's propanol. And I'm done naming alcohols. Okay, to name carboxylic acids look like this. C double bond O, OH with this like C. Okay, so I take a look at this and I'm like, okay, why is this not an alcohol? Why is this a carboxylic acid? Okay, it's a carboxylic acid and not an alcohol because it has an OH like an alcohol, but it also has this double bond O. That makes it a carboxylic acid. Okay, and just to let you guys know, it actually shows you how to name everything here. So like here, see how they have this alcohol here? They named it met. Like see how it has 2, they already named it for you, ethanol. 2 carbons, ethanol. Carboxylic acid, 2 carbons, you can see it, they call it ethanoic acid. So what would be the name of this? Okay, again, you identify the longest carbon chain. That's these. How many are in this chain? 3 carbons in the chain. Well, how do I name carboxylic acid? The ending is oic acid. So the name of this would be, okay, 1, 2, 3. 3 is prop, right? You know it's prop because it's in your book. Prop, C3. Okay, so this would be called propanoic acid. Easy. Okay, now if you had this, hey, is this a carboxylic acid? Well, yes, it is because there's an OH and a double bond O. What's the longest parent chain? 2 carbons. What would be the name of this? Ethanoic acid. Why? Ethane for the 2 carbons. Oic acid because it's a carboxylic acid. That's all you do. And you now learned how to name a carboxylic acid. Okay, now esters. Hopefully that makes sense, guys. Okay, to name an ester is basically an alcohol plus carboxylic acid. Okay, so can you imagine like you have an alcohol here. Okay, this is an alcohol because it's OH with the COH. And what's the parent chain? Well, there's only one carbon. So, hey, this is methanol. Okay, the OL ending because that's an alcohol OH plus a carboxylic acid C double bond O OH. Hey, guess what? I know this is a carboxylic acid because it has an OH and an O, and the name of this is ethanoic acid because the longest parent chain is 2 carbons. See this is methanol. This is ethanoic acid. When I put these two together, I get an ester. So what does the ester look like? The ester would look like this. That's what the ester looks like. See how these 2 carbons came from the ethanoic acid? See how we had 2 carbons here, 2 carbons here? So these 2 carbons, these 2 carbons, that alcohol, the methanol, gave me that part of the ester. Okay, so this is called an ester, and then you got to name it. Okay, so how would you name this? Well, this would be called, okay, this would be the parent chain. So the parent chain is always the carbon chain that's connected to the double bond O. Okay, so the parent chain would be ethanoate, and that would make this other carbon the branch. Okay, so we're just going to draw this out again and make sure you guys understand this. Okay, so here's an ester. It's a C, right? And then it's attached to an O, which is attached to a double bond O. And here is the H, and H. Okay, so that's what I drew here. This, right, is the branch. Okay, that's the branch. And this is the parent chain. And you can see the parent chain is the one where the carbon is attached to the double O. That becomes the parent chain. Right? The branch is separated from the parent chain by the O in the middle between them, and you name the parent chain. So the parent chain is 2 carbons, 1, 2, so it's going to be F, and then it actually shows you how to name it in your data book. Okay, so you can see the very same one that I drew on the board is the one in your data book, and the parent chain, the ending is going to be F08. Okay, so the ending is O8, so this is going to be ethanoate, ethanoate. Okay, that is the name of the parent chain. O8 means we're dealing with an ester. What is an ester? An ester is when you have an alcohol joined with a carboxylic acid to produce this compound. Okay, you can see it doesn't look like an alcohol because there's no OH. Okay, it's not a carboxylic acid because again we're missing the OH with the, it does have the double bond O, but it's missing the OH. This is an ester. Okay, it has a carbon here and 2 carbons here, and these carbons are attached by an O. Esters make things smell good. Like anything that smells good is an ester. Okay, so you just named the parent chain of the ester, and now you name the branch, and the branch is called methyl. So you name the branch with the YL, methyl ethanoate. Okay, we'll do another one, okay? So let's quickly do another one and make sure everybody understands this. Okay, so here's another ester, okay? Okay, so now I gotta take a look at this, and I'm just like, oh, which one is the parent chain? Okay, this has to be the carbon with the parent chain. Y1, 2, 3. Okay, it is the parent chain because this carbon is attached to the double bond O, so this becomes the carbon chain on this side of this oxygen, okay? This side of the oxygen then becomes the branch. Okay, so I named the parent chain first. 1, 2, 3. 3 carbons is prop, because I'm dealing with an ester. The ending is O8. So guess what? The parent chain is called propan-O8. Propan for the 3 carbons, O8 because it's an ester. The branch is going to be ethyl. There we go. Ethyl propanoate. That's how you do it. Okay, I hope that helps. The only last thing I want to talk about very, very quickly in my last couple minutes is what BOD is. So that is BOD, biological oxygen demand. So basically, like if you have a lot of waste in a pond, and all of this is like waste. Well, the bacteria in that pond, here's all this bacteria, uses up the oxygen. So it uses up the oxygen to break down all this waste. So, you know, here's all, okay, so here is these waste, here's this bacteria. The bacteria is breaking down this waste, and they're using up all the oxygen in the water to break down this waste, okay? So that means you have a high BOD. That means you have a high biological oxygen demand. That means that these bacteria have a high demand for oxygen. So the more waste you have, the higher the BOD. And the less waste you have, well, the less bacteria are using up all the oxygen, the decrease in the BOD. You want lower BOD. Lower BOD means that there's less waste. And because there's less waste, there's less bacteria that are eating up the waste and and because there's less bacteria eating up the waste, there ends up being more oxygen, right? So again, if you have a lot of sewage and you have all these bacteria breaking down the sewage, they're using up all the oxygen in the water. To break it down, your water's going to have, right? Your water's going to not be that great, right? So a high biological oxygen demand means you have lots of bacteria that you're using up all the oxygen in the water to break down waste. Okay, so that's my last lesson. You guys can do your assignment for this unit. I will post and get it done. I mean, here's some extra practice if you need it. I hope this helps, guys. Okay, take care. Bye.